3, Lesson 6, Introduction to Programming. In this lesson, and in Lesson 7, because these are going to be done together, you will be able to define a program as a sequence of commands that are executed or run by a computer. You'll be able to explain the differences between how sequential and event-driven programs execute, and you'll be able to define comments as notes or documentation into a program that do not affect how the program executes. Let's get going. First, head out to code.org, log in, and go to Unit 3, Lesson 6, Level 2. This is what you're going to see right here. Now, what do I want you to do here? Well, I want you to work first at Level 2 on the 3 tasks for a few minutes. Now, if you get through those 3 tasks, feel free to move to the next 3 tasks, because at some point you might get stuck. But as you're working on your tasks, I want you to jot down things that you notice. What do you notice as you run the code? What do you notice happens in all the different parts of the windows? Okay, notice I'm going to go over some important things that you should notice. But you're going to be doing this on each level. On each level, you'll have 3 minutes, and then I will call you back together for about a minute to go over what happened. And then you'll go to the next level. All right? So go ahead and pause this video and spend about 3 minutes on Level 2. Fantastic, you're back. So, after completing the tasks, did you notice that the code runs one line at a time? Strings need to be in quotes. Strings are those sentences, text, even numbers that are text. They need to go in quotes. However, numbers do not need to go in quotes. Yellow highlighting shows you which line of code is running in either the block or the text mode. It doesn't matter which mode you're in. The turtle slider, that's this guy right here, the turtle slider changes the speed at which the code runs. At full speed, all the way over here to the right, there is no longer any highlighting because the program actually executes too fast for you to just see all the highlighting. Now, move on to Level 3, if you have not already, and work for a few minutes. What should you notice after doing the tasks? Well, that's what you're going to tell me. So go ahead and pause. You're back. So, on this level, did you notice that the console.log prints text in the debug console down there at the bottom? The set property changes the properties of elements on the screen. These should be familiar from using the design mode. Console.log needs 1 input, while set property needs 3. Hovering over a block in the toolbox helps you know what kind of information to put in each input. Okay, if you need to as well, when I pause, you can either write these down or say, hey, yep, I noticed all this, or take a picture of it. Your choice. You can also rewatch this video. Now, Level 4. Move to Level 4 and give yourself 3 minutes. You're back. Okay. The on event makes the program respond to the user. You can add code inside of it that will only run when something happens. So on event says, when this event happens, whatever that event is, I want something else to occur in the code. Changing the second input changes the type of interaction that will make the code inside the on event run. Code outside the on event runs right away. Code inside an on event will only run when the event happens. Even if code is after an on event, it will run first if it's outside of any on event. Okay? All right. Move on to Level 5 and try those things. All right. Now that you've completed the 3 prompts in Level 5, did you notice that Play Sound will play a sound you pick from the sound library? And did you also notice that lines starting with the double slash mark are called comments? They don't actually run. They just help you understand your code. You will need to use comments. If you want me to help you debug your code, you will need to use comments. You're going to need to tell me what that next line of code is supposed to be doing, or what that next little block of code is supposed to be doing. Okay? Now, go ahead and go to level 6. Okay, things that you should have noticed. Random number chooses a new random number each time between the high and the low value given. On event takes many different event types, not just mouse over and click. Depending on the situation, different ones make more sense. Okay? So on event does lots of things, random number, new random number each time between the high and the low. Now, to wrap up, think about your experiences in this lesson and in the previous lesson. How is a programming language different from a natural language? Pause the video and jot down your thoughts. Why is a programming language different from a natural language, or how? Okay? Well, programming languages are much more precise than natural languages. Programming languages have very strict rules. Programming languages may feel a little awkward at first. Okay? The other thing is, you can't just make something up and everybody agrees. Programming languages have set rules. Now, some of your vocabulary. Program statement. This is a command or instruction, sometimes also referred to as a code statement. A program is a collection of program statements. Programs run or execute one command at a time. 2 different ways for programs to run. Sequential programming. Program statements run in order from top to bottom. Starts here, runs down. There's no user interaction. The code runs the same way every time. As soon as you click run, it just goes right through the code. Now, event-driven programming is a little bit different. Some program statements run when triggered by an event, like a mouse click or a key pass. Programs run differently each time depending on the user interactions. So if the user never clicks the button, this code will never execute. If they click it a lot, this code will just execute a lot. Now, we're going to move on into debugging because these are 2 very short lessons. In this one, debug simple sequential and event-driven programs. You'll be able to use the debugging process and identify specific best practices for debugging programs, which also means fixing them, and use the speed slider or breakpoints and documentation as part of the debugging process. Now, your friend calls and says, "Hey, I can't get music to come out of my speakers." Think about what would you ask them or have them check to try to fix the problem. Well, a couple things. First, you got to know, are they wireless or wired? If they're wireless, is the Wi-Fi up? Is the Bluetooth connection set? If they're wired, is there a loose wire? Are they plugged in? You might check the volume, things like that. There are a lot of different things that you could check. Now, let's go ahead and watch this video. And if you are watching my video asynchronously, you need to pause and go out to Canvas and click on this video to watch it. It's a YouTube video on the debug process. It's only about 2 minutes long. Now that you finished watching that one, let's look at the debugging process. There are 4 steps. 1, you've got to describe the problem. You can't just say it doesn't work. What doesn't work? What do you expect it to do? What does it actually do? And does it always happen that way? Is it something that happens all the time, or is it intermittent? Then you're going to hunt for bugs. Are there warnings or errors, anything that comes up in when you compile or when you run it? What did you change most recently? Since the last time you ran it and it worked, what did you change? Explain what your code does to someone else, and as you're explaining it, look for code related to the problem. Sometimes just talking through it makes a huge difference. Try solutions. Make a small change. put in an output statement. See what happens. See if you get there. See if the values that you think are going through are really going through. Document as you go. What have you learned? What strategies did you use? What questions do you have? What things did you try to do to fix it? And what happened when you tried those things? It's important to document because you don't want to redo something over again. Keep your code clean. Use meaningful IDs for your elements. Somebody looks at something, they should know what that window does or should have an idea of it. Keep your code organized in chunks that do the same thing and use comments to explain your code. Write code using blocks. Use white space. Blank lines in between different chunks of code. Don't cram it all in. Run your code often. After every time you add a couple of commands, run it. Does it still work? Is it doing what you think it should? Slow down your code with the speed slider and watch how it runs. Use the console.log to get output. Add extra output statements throughout your code to get feedback on what parts are running. Did you get to a certain spot? What are the values? Are those the values you should expect? Use your classmates and resources. Talk out the problems with a partner or classmate. I've had many students start explaining what's going on only to immediately realize and see what they had done wrong. Compare your code to examples that you know work. Read documentation to know how a block is supposed to work. Hand trace your code to track what's happening. Unless it's something like the create test, you can look at somebody else's code and your code and see what's going on. You might be using different pictures, but see if you're missing something, a comma, a statement, something. Now, documentation, that's a written description of how a command or a piece of code works, okay? That's this, and you've got all this documentation here. It's like a user's guide or a user's manual. A comment, on the other hand, is a line or two that is embedded into the code. It does not execute, the computer ignores it, but other programmers can look at it to see what is this code supposed to do. Next class, you're going to resume work on your app. Are you ready?